In this video, we're going to continue with what we were learning about inductive reasoning and conjectures, but now we're going to find something called counterexamples. So if your conjecture is false, it's false if there's even one conjecture that we can come up with that's not true. In other words, if you can come up with a statement that would make a conjecture not true, it's called a counterexample. So counterexample is just something that you're using to prove that your conclusion is not necessarily true. So in example 1, we're going to find a counterexample to show that their conjecture is false. So here they're saying angle 1 and angle 2 are adjacent angles. Remember, adjacent means next to or side by side. They're saying then angle 1 and angle 2 form a linear pair. So you have to understand what a linear pair is here. So a linear pair means they form a straight line. So angle 1 and angle 2 would form a straight line. We want to come up with a counterexample. So we want to say, okay, they can be adjacent, but they don't necessarily have to form a linear pair. So I can draw other types of angles, like let's say we could draw complementary angles for angle 1 and 2. These are still adjacent because they're right next to each other, but they don't form a linear pair. They actually form a right angle. So this could be a counterexample. To the statement that they form a linear pair. So they can be adjacent or next to each other and not necessarily form a linear pair. Here we're going to determine whether the conjectures are true or false. If we can come up with even one counterexample, then it's false. So if we can come up with one, we need to give it, and then we'll state that it's false. If there's none that we can come up with, then it's a true statement. So question 2 says angle 1 is complementary to angle 2. We know that that means they add to 90 degrees. And then angle 1 is also complementary to angle 3, meaning that these also add to 90 degrees. It says angle 2 is congruent to angle 3. Well, angle 1 could be any number. So let's say angle 1, measure of angle 1 is 60 degrees. And if it's complementary to angle 2, then angle 2 would have to be 30 degrees. Again, angle 1, we need to be consistent with it. So if angle 1 is 60 degrees, and it's also complementary to angle 3, then angle 3 would have to be 30 degrees. So our conjecture here is that angle 2 is congruent to angle 3. Well, since angle 1 is complementary to both angle 2 and angle 3, they have to be congruent for them to add up to 90 with angle 1. So this is actually a true statement. Our next question says if angle ABC and CBD form a linear pair. So let's go ahead and sketch this out. We have ABC. And CBD would also have CB, so it would just have a D on the side. It says they form a linear pair, so straight line. Then angle ABC is congruent to angle CBD. Well, if you look at our picture, they're not congruent. ABC is obtuse and CBD is acute. So this in itself would be a counterexample. And if you can come up with a counterexample, then that means your statement is false. Congruent would be like if ABC and CBD were both 90-degree angles, but it just said that they're a linear pair. So for them to be a linear pair, they don't necessarily both have to be 90. One could be acute, one could be obtuse. Question 4 says angle ABC and angle DEF are supplementary. That means they add to 180. And then if I draw these out, so ABC and DEF, I'm not putting these touching each other because they don't contain common points. But I know they're supplementary, so they have to add to 180. And then it says angle ABC and DEF form a linear pair. Well, they form a linear pair, they would have to be touching each other to form that straight line. These cannot touch each other because they don't have common points. So even though they both would add to 180 like a linear pair and supplementary do, like this could be 120, this could be 60, they're not going to be a linear pair because they can't be touching since they have different points on those lines. So this would be a counterexample. And since we can come up with a counterexample, that means the conjecture was false. So again, if you can come up with anything that goes against your conclusion, that's called a counterexample. Even one counterexample is enough to prove that a conjecture or conclusion is false.